Good morning, everyone. Thank you for joining us. Welcome to the webinar, Value Stacking with Demand Response in HOMER Grid. I am Steffi Klawiter, and I will be doing the introduction for this webinar, and then I'll hand the mic over to RB, who will take us through a sample file showing off the demand response feature in HOMER Grid. Just a quick intro for those of you who are new here. HOMER is the global standard in economic design analysis. The main point of our software is to find the best mix of resources at the lowest cost over the project lifetime. So HOMER gives you project sizing and design, which ensures you that the load requirements are met by the generation supply sources. And it's both an economic and an engineering tool. We've been around for over a decade. We got our start at NREL over 10 years ago. So in the most basic sense, our software works from you define your inputs, and that is the on-site economics, how much energy do you need on-site, what components may you be considering, where's your location, and what are your solar or wind resources. Then it goes through the calculation in either HOMER Pro or HOMER Grid, and ultimately you can come up with the engineering and economics for the system. And you can take those sizing, that sizing design, and move that into the next phase of design or your financial analysis as the project lifecycle goes on. And so what makes HOMER so powerful is actually what's inside. We start with a simulation, which is for the full year, every time steps in the year, you're testing different sizing and system configurations for that whole year. And so depending on the model that you set up, you can have hundreds or thousands of different simulations in a run. HOMER is a very, very powerful and robust tool in that way. And the time steps can be an hour long, or they can be down to a minute long. Once you have your simulation, the simulations are ranked by the net present cost, which the winning system is our lowest net present cost system. Additionally, HOMER allows you to do risk analysis on certain variables that you may not have control over, like fuel price. So you can investigate how your ideal system architecture and sizing depends on these uncontrollable variables. And this is how HOMER helps you to future-proof your system design. So just putting it together, your inputs get run through HOMER Pro or HOMER Grid, and ultimately give you the answers that you need. Our products have been used all over the world for a variety of different applications, and the use cases have become so different and so complex that we actually have two different products to help our users. So to understand what product is right for you, the first question you can ask is whether you're grid connected. As the name would suggest, HOMER Grid is designed for grid connected systems, most simplistically. HOMER Grid has a dispatcher that's specifically designed to reduce your monthly demand charges. So if demand charge reduction is important in your project economics, HOMER Grid is the right tool. And HOMER Grid is specifically designed for commercial project developers trying to evaluate the engineering economics. HOMER Pro is our flagship product and has a wider range of capabilities. And so it's useful, especially in the island microgrid world, or if you have, if you're connected to a grid that is so unreliable that you want to model scheduled outages, for example, or grid extension, if you're considering the cost of extending the utility grid versus the cost of being off-grid microgrid, HOMER Pro is the right tool for that. HOMER Pro has additional technologies such as hydrogen and hydrokinetic power generation modeling. So the flexibility of HOMER Pro is greater, and you can have the option to create your own dispatch strategy or custom component. And all of this flexibility is one reason why HOMER Pro is very popular in especially academia. So hundreds of papers have been written based on HOMER Pro. For HOMER Grid, we are, as I mentioned, focused on specifically behind-the-meter distributed generation. And the value streams that HOMER Grid considers are, I mentioned demand charge reduction. That's the value stream that we kind of started with, the core of what HOMER Grid does. And the dispatch is designed to reduce those monthly demand charges. HOMER Grid can consider the value of self-consumption, where by installing on-site generation, you're reducing your utility bill. Incentives, by which I mean kind of regulatory incentives, such as the ITC or production credits that you may get as a value stream for your project. Energy arbitrage or price arbitrage actually is what HOMER Grid can consider, which is using the battery to ensure that the energy is purchased at the lowest possible rate, or even capitalizing on the battery's ability to buy at low price times and sell at high price times, if that's economic. If reliability and resilience are important to your project economics, HOMER Grid can take that into account as well in its economic analysis. And we're announcing demand response as the latest whole new value stream. And demand response can be very important for project developers who'd like to consider this extra value stream, and it will impact the sizing and the economics of especially dispatchable resources like batteries. So just quickly, what is demand response and why does it matter? So demand response programs are offered by the utility, and when the system demand peaks at close to the generation capacity of the grid may become unstable with blackouts and brownouts. So generally, this could be on weekday afternoons of summer months because of the air conditioning load. So as a way for utilities to avoid adding additional peaking generators, which are very expensive because they sit idle for most of the time, except for those 1 or 2 times per year when they need to jump on, the utilities are choosing to set up demand response programs which call on their customers to reduce their electrical demand during certain dates and times. Generally, the end-use customers will opt into a demand response program, and on days when the utility expects to have a high system demand, they will give advance notice to these customers that have opted into the program, so the customers can reduce their load. In reality, it's common to work with curtailment service providers, excuse me, or load aggregators to ensure that the load is reduced in order to effectively capitalize on these demand response programs. And so demand response is happening not just in the United States, as this graphic suggests, but there's programs internationally incentivizing end users to alter or change their demand profiles. And so technology has been a major driver in this, in allowing end users to participate in these programs with minimal effort. So thermostats, water heaters, and controlling the AC units make up the majority of the enrolled capacity. In the U.S. alone, many utilities are starting to offer these programs, and it's especially important in the C&I sector. So most C&I facilities who partake in DR programs actually do choose to alter their load. They can reduce their load during the demand response event, or they can dispatch on-site generation. And in this way, HOMER can consider these 2 options. You can consider turning off the non-critical load to model load reduction, which would be just like turning off your AC units during the event. And HOMER has the ability to consider dispatching your batteries or generator in order to meet the critical load and avoid grid purchases during the DR event for that non-critical load. So just a sneak peek at what we'll see ahead. In HOMER Grid, you have 3 options to specify the demand response event. You can specify a kilowatt value to which you want to reduce your load and meet the bid, or you can say that you're going to reduce your consumption by X number of kilowatts, or you can allow Homer to optimize each event and find the best bid for you. And so the baseline is kind of a definition that we'll bring up later, but the baseline is what you define as your critical plus non-critical load in Homer grid. And so if you say you're going to reduce by 100 kilowatts from the baseline, in this picture, the load during this demand response event is at 250 kilowatts, and we're reducing by 100 kilowatts. So you can see the purple bid limit is where we're going to reduce to. And so during the demand response event, the load is served by a combination of the utility and the renewable generation sources. And the battery is discharging, but just a little bit. With that, I will turn over the mic to RB, who will give us a more complete demonstration of the feature in Homer Grid.
Thank you, Steffi. Today we're going to model demand response in Homer Grid. Now, if I were a commercial or business owner and my utility was offering these demand response programs, some of the questions that I would like to answer would be, how do these programs differ from each other? How much could I potentially save under each program? I would also like to know how many kilowatts I should pledge to reduce during each event. Let's say I do not already have a battery or generator. What size of equipment should I be investing in to ensure that I meet my bid? These are some of the questions that we are going to answer today using Homer Grid. Today, we're going to model Con Edison's demand response program called the Smart Usage Rewards. Con Edison, a utility in New York, has designed two demand response programs, the DLRP1, Distribution Load Relief Program, and CSRP, Commercial System Relief Program. You're allowed to enroll in both these programs. Under DLRP, you get only 2 hours of advance notification. And hence, as you can see, the reservation payments are significantly higher than the other one. In both of these programs, you're required to provide up to 4 hours of load relief. It's interesting to note that you will receive these payments regardless of whether Con Edison declares an event. Before signing up for either program, it's good to get a sense of how often in the past have events been called for either. According to the Con Edison website, the DLRP program has called 6 events in both networks, while 0 events have been called under the CSRP one. The DLRP is triggered due to network congestion, while the CSRP program is declared depending upon the forecast for the next day. The DLRP can occur on any day, including holidays, except between the hours of midnight and 6 a.m. The CSRP program, on the other hand, gets called only on weekdays and it does not include federal holidays. Assuming you're already a customer of Con Edison, then to sign up for their Smart Usage Rewards, you have to go through a few additional steps. You would need to install a special billing meter that is capable of tracking and recording your baseline load. This is critical to calculate your load reduction during the event. In the table on the right, you can see the prices for the various meters from the Con Edison website. The next step is to sign up with a load aggregator. Con Edison has pre-approved a list of third-party companies for their customers. So if you're a customer in New York and you want to sign up for a demand response program, it has to be through one of these companies. The final step is to register your bid or the amount of kilowatt you pledge to reduce when called upon for an event. Now let's model Con Edison Smart Usage Rewards using Homer Grid and answer the questions on the right. I'm using Homer Grid 1.5.0 that is releasing later today. I'm going to enter the location as Upper West Side in Manhattan. So let me choose an industrial load for this example. My next step is to add an electricity tariff for this region. For those of you who have been using Homer Grid, you might observe that this user interface might look a little different. So let's take a minute to understand the statement. Same company provides both electricity generation and distribution services. Typically, electricity is generated in one location and then reaches your home or business using the transmission distribution network. In deregulated markets such as New York, you could have Con Edison providing the distribution services, but another company actually generating the electricity. So if you click yes to the statement, does the same company provide both electricity generation and distribution services? Then the tariffs that are provided by Genability will include both generation rates and the distribution rates. Now, if you click no to that statement, you're essentially saying that one company distributes electricity while another company generates it. In this case, the tariffs provided by Genability will only include the distribution charges. So let me demonstrate this in this example. I'm going to click no to this question and then choose the general extra large time of day hourly EL9 tariff from Consolidated Edison. Since I just clicked no to the statement, I've now chosen a tariff with just distribution rates. I now have two options to include my electricity provider rates. I can choose to enter a flat generation rate, which is a fixed dollars per kilowatt hour that will apply at all times. Or if I do have my generation tariff, I can build it using our advanced tariff builder application and import that JSON file and combine those rates with the distribution rates. So over here, I see both the options. I'm going to enter a flat generation rate of 2 cents per kilowatt hour. My next step is to add a demand response event. I'm going to first be modeling the CSRP program. The CSRP program had a demand reduction incentive of $6. What this means is the utility pays me $6 for every kilowatt that I reduce. At this stage in my modeling, I do not have a sense of how much I should bid for. So I'm going to let HOMER optimize the demand reduction. I can choose to enter specific dates when the utility would call the event, or I can let HOMER pick random dates between a time frame. So I know that these events occur between May 1st and September 30th. Let's assume that 9 random events have been called. A CSRP can occur only on weekdays and can happen at any time. And for each event, the duration is 4 hours. Now I'm adding the second demand response event under Con Edison, which is the DLRP program. If you remember, the DLRP program is the one with the higher demand reduction incentive of nearly $18 per kilowatt. So the utility would pay me $18 for every kilowatt that I would reduce. Similar to the CSRP one, I would like HOMER to optimize demand reduction. Events under the DLRP also occur from May 1st to September 30th. Let's assume that 12 random events have been called, and they can occur on any day except between the hours of midnight and 6 a.m. So let's assume a starting of 7 a.m. until 7 p.m. and each event lasts for 4 hours. Now I want to model 4 different scenarios. The first scenario where I do not sign up for either demand response program. A second scenario where I sign up for only one of those programs. And the final scenario where I sign up for both of these programs. I can model these 4 scenarios using HOMER Grid's sensitivity analysis. So the first sensitivity has me enrolled in both DLRP and CSRP programs. Neither programs, only the CSRP one. And the last sensitivity is only the DLRP program. My next step is to add a PV component. So let's assume that this building in New York already has an 80 kilowatt PV panel. So I entered 80 over here in the sizing, and you can see that over here, the capital cost is zeroed out. This is because I've already purchased this PV panel and it's a sunk cost. So I do not want to consider that in my economic modeling. I'm also interested in purchasing an energy storage system for this demand response program. So I'm going to add a 1 kilowatt hour lithium ion battery. I'm going to let Homer optimize the size. My final step is to add the cost of the special billing meter. Let's assume that I chose the most fancy meter from Edison, and that price was around $2,222. And that is now in my system fixed capital cost. Now let's see how much savings I get under each of those 4 scenarios. I'm going to open a saved results for this exact model. So let's take a look at that. So the first simulation you see over here, the first sensitivity, has me enrolled in neither program. Since I'm enrolled in neither program, I do not need to purchase a battery. This simulation has the highest net present cost of $7.18 million. The next simulation has me signed up for only the CSRP program, and HOMER Grid has estimated a battery size of 90 kilowatt hours of lithium ion batteries. There's slightly lower net present cost. Let's look at how much savings I get by signing up for the CSRP program. So I get a utility bill savings of $7,000 per year and a total bill savings of $92,000 over the project lifetime. The next sensitivity has me enrolled only in the DLRP program, and I can see that the battery size is increased to 108 kilowatt hours, a definite drop in the net present cost, and a significant increase in the utility bill savings and total bill savings. My last sensitivity has me enrolled in both the DLRP and the CSRP program. And it's interesting to note that for the same amount of batteries, it makes sense to enroll in both programs because I get significantly the highest utility bill savings and the highest total bill savings. If you would like more information about the demand response event, pick a simulation, double-click it, and proceed to the DR Events tab. Over here in the drop-down, you can see a list of all the events under both programs. So what this means is, for the DLRP event called on 29 September, starting at 7 a.m., HOMER Grid was able to reduce grid purchases by 38.7 kilowatts. And this led to a demand reduction incentive of $697. Similarly, you can switch to any other event to view how much we reduced. If you would like a list of savings under each demand response event, click on the Utility tab and then the utility bill details. Over here, you can see a line item for each demand response event and a total savings during that event. So let's summarize what we learned in the most recent model. If we decided not to enroll in both the programs, we do not need to purchase any batteries, but obviously the demand response incentive earned is $0 per year. If we decide to enroll in only one of those programs, we do need to install some batteries, and there is significant savings higher for the DLRP program. But the highest savings is when we enroll for both these programs for 108 kilowatt hours of lithium ion battery, which has a simple payback of almost 4 years and an IRR of 23%. So next question that we're going to look into answering is how to get an estimated bid or pledge amount. So in this model, I do not want to do any sensitivity because I want to enroll in both the programs. So over here, I've removed the sensitivities for DLRP and CSRP programs. I'm going to continue to let HOMER optimize the demand reduction. So let's see the results for this model. So if you pick an event that happens on 28 September, you know that the optimized demand reduction bid that Homer suggests is 175 kilowatts on this date. This led to a demand reduction incentive of $3,000. I made a list of all the demand reduction bids that Homer optimized for each of those events and summarized them in a table over here. On the left are dates under the DLRP program and the load relief provided during each event. There's a similar table for the CSRP program on the right. Looking through the range of load relief and Homer's optimized reduction, you could come up with a conservative bid or maybe an average bid or a risky or aggressive bid that you can submit to your utility. The next question that I would like to answer is, what is the size of the battery I should be purchasing in order to ensure that I meet my bid? So now I get a sense of what my bid should be. I'm going to pick the average bid across what Homer optimized. So I'm going to put in reduce by 216 kilowatts for the DLRP program and reduce by 157 kilowatts under the CSRP program. Now let's calculate and figure out what is the most optimal battery size in order to meet both those bids. So the winning simulation has 1,131 batteries. If you click on the overall results, you can see that Homer is optimized with a range of battery sizes. And this simulation is the one with the lowest net present cost. You can visualize this better using the optimization plot. I'm going to select the net present cost on the x-axis and the total operating cost, which includes the utility bill. So over here, you can see that the simulation with the lowest net present cost and lowest operating cost is the battery size of 1,131 kilowatt hours. So let's summarize our last model. To meet a DLRP bid of 216 kilowatts and a CSRP bid of 157 kilowatt, the optimal battery size is 1,131 kilowatt hours. So this concludes our software demonstration of demand response in Homer Grid. Handing it back to you, Steffi.
Great, thank you, Arby. Excellent. So I hope that from this webinar you can see the power of demand response and how it can affect your system design and help you capitalize on these additional value streams. Just to note, we have multiple different help resources if this webinar wasn't enough for you, or if you have questions on other things. We have an online user manual. We offer premium support as well as our basic support. We have a knowledge base website where we post commonly asked questions and a community forum where users answer other users' questions. So if you in your team don't have necessarily the bandwidth to use the Homer software suite to do your projects, we can do consulting for you, and smaller consulting is usually under premium support where we can help you, or customized training as well. And now I think we will get to the questions. I know that we've had a ton of questions coming in that Leah's been answering. So let's see. One question we had was, can you enter specific dates for demand response events instead of letting Homer choose the dates? There's two different ways within demand response in Homer Grid to specify the dates. You can either do the random dates or you can choose specific dates. So the answer is yes, and the toggle buttons are right in the middle of the page. Next question, can you model demand response with multi-year? So in case you don't know, Homer Grid and Pro both have this multi-year feature, which does a simulation for each year of the project's lifespan individually. So yes, you can model demand response with multi-year. And if you use this random dates setting, actually there'll be different dates for each year. So that's kind of a neat way to do risk analysis on the specific dates. Arby If you want to jump in, you're welcome. Otherwise, I can maybe I'll answer one or two more that I have here.
Yeah, some of the questions that are coming in are, can we model demand response programs in Canada?
Yes, so you can set up your own demand response program here. Right now, our library of demand response programs that exist isn't filled out, so everyone needs to customize using this interface their demand response program. And so there's no difference between Canada or US in terms of how this demand response feature works.
Thank you, Steffi. Is it possible not to serve some of the load during a demand response event?
Yes, so I think what we demonstrated was serving the electric load here. If you wanted to specify a load that could be cut off during that demand response event, you would go to the non-critical load, and under normal grid operation, the energy that would be served is the sum of the electric load and the non-critical load, or the critical load and the non-critical load. Some will be served, and then during outages and during DR events, the non-critical load will not be served. So there's should be a shortcut right here. The non-critical load will not be served during the DR events, and that's how you get to the non-critical load.
Another question is, how do I get tariffs for South Africa?
Yeah, so it wasn't explicitly mentioned, but we have several different ways that you can create a tariff. In HOMER Grid, we are connected to a tariff database. Unfortunately, for international users, this tariff database only covers North America. So if you're in North America, it's useful. If you're not, we have an interface where you can build up just a simple flat energy charge, demand charge, and fixed charge. Or we have a much more complicated tool, which is much more able to capture the complexity of utility tariffs around the world, which is right here. And so you can create your own utility structures. If you're in, for example, South Africa, you'll be using this tariff builder tool.
Yeah, thank you, Steffi. I think I'm going to take the next question. The question is there a website where we can find out about utilities demand response programs and the incentives? So I think it's specific to the utility that your customer is in. I'm not aware of one single website that spans all utilities, even in the US. For the example that we showed today, I found all the information on the Edison website. Steffi, another question that we have is, how do I add incentives to my HOMER Grid model?
Oh, great question. Yeah, so we've grouped demand response events and incentives under this program's expander here. And so for incentives, we have a number of different templates. So if your incentive is based on how much initial capital you put up, you can use the capital-based template. There's a depreciation template and a capacity-based template, as well as a production-based template. There's a couple specific US incentives listed here as well in the library. But for example, if you're looking for an incentive based on cost or incentive per kilowatt hour produced, you could use this production-based template, say which generation source it applies to, and then define how much it is, whether it's limited in years, and whether it is taxable. So there's several different templates, and again, this is part of the inputs that you'll need to define up front going into the model. We are aware of some incentive databases, but it's unsure how quality they are. So for now, users have to define their own incentives.
Thank you, Steffi. Another question that we have is, I want to create a new battery to use in HOMER Grid. How do I go about doing that?
For batteries, you can change certain inputs within the HOMER Grid interface, like the cost or like the site-specific information. But when it comes to kind of the nuts and bolts of the battery, you'll need to go to the library view. And in HOMER Pro, there's an equivalent library view which you can see. So in the library, you can see the full list of what's in Homer's library and what's in your user library. And for specific components, you can see exactly what parameters go into this battery model and define the battery. So we have multiple different battery models. This is a idealized model. It's a more simple model. Where we have the advanced storage model, which is a bit more complex, and all of that is viewable within the librarian. So in this advanced storage model, you can see there's multiple tabs that allow you to specify rate-based capacity, how temperature may affect the available capacity, what the cycles, how you're cycling the battery may affect the lifetime of the battery, and how temperature may affect the shelf life, as well as thermal degradation. And so the librarian allows you to see everything that goes into the battery specifications and customize those based on a battery specification sheet. So in general, we try and have this model somewhat align with information that you should be able to get from the manufacturer for specific battery models. And then you can add your custom component into your model within HOMER Grid. And in bold is your user components, non-bold is the HOMER library.
Thank you, Steffi. I think I'm going to answer the next question. Is the HOMER Grid optimization evaluating the trade-off between using the battery for demand charge reduction and using it for a DR event? Yes, this is part of the peak shaving dispatch that compares the cost of each of those decisions. So I've seen cases in which the battery wear cost is significantly high. So HOMER decided not to reduce any load during the DR event. So that sort of comparison definitely happens in the peak shaving dispatch. Yeah, I think those are about the questions that we have gotten so far.
I think you answered this maybe during the webinar, but there was a question about how do I add a distribution tariff to generation tariff to the distribution tariff?
Yeah. So let's say your generation utility actually had a set of rates that they have published online. So once you pick your distribution tariff, you can then open the advanced tariff builder application, create your generation tariff, enter your consumption rates, your demand rates, or your fixed and other charges in the advanced tariff builder application, and then save this JSON file on your desktop. Yeah, and then import that JSON file in the second radio button option, and that will combine the generation tariff that you just created with the distribution tariff from Genability.
Great, okay. Well, I think we've answered most of the questions. If you have further questions, feel free to reach out to our support team or recognize that there are the options that I mentioned before, the help manual, the knowledge base, the success forum, in addition to our support team. So thank you for joining us today. Our next webinar is going to be hosted by Dr. Peter Lilienthal, the CEO of HOMER Energy, and it will be inspired by, he's traveling to Ghana with World Bank for a conference there. So he'll be talking about what he learns about mini grids that's happening in the field right now. So please join us there and stay tuned for the date. Of course, thank you to our HOMER Energy partners. We appreciate your support. And thank you to all of you for your time. We look forward to working with you and getting your feedback on demand response. So thanks very much.